All right, so first day of a 2-day study for Cycling Magazine for riders, RS, T, and Y. We'll each test one of 4 bicycles. Okay, so each of these guys is going to be matched with one of these 4 bicycles. Okay, and then they'll test a different one on the second day. So day 1, day 2. Right, and we have to have them test a different one, day 1 to day 2, so these can't be the same, right? Each rider tests only 1 bicycle per day. All 4 bicycles are tested each day, great. So R can't test F, Y can't test J. Teresa must be one of the testers for H. I'm just going to go ahead and split that one. Okay. R, S, T, Y. Still don't have J there. Still don't have F there. So we can have H being the first one it tests, or H being the second one that it tests. And Y test, okay, on the first day, the bicycle that Y tests on the first day, so this one right here, must be tested by Seamus on the second day. So these two have to be equal, have to be the same bike. Okay, this is the one that we want to figure out which one it is and which one, like, it can't be, right? So it can't be J. Okay, so for that, I'll just actually use this list here. Can't be J. Also can't be H. It can't be H because Teresa has to take H one of the days. So it's either F or G. Okay. All right, so question 16. Which one of the following cannot be true? Seamus tests F on the first day. Okay, so what would that look like? Using pencil again, handy for these tough games with the diagrams that you don't want to keep redrawing. So, sorry, cannot be true. Ronaldo tests G on the second day. That was the, so G here, which would mean this is F, right? Anytime we eliminate G from being the one that's here, it's got to be F. If we eliminate F, it's got to be G. So if we were to do that, this can't be G, this has to be H, which means this is J. We've got J or G. Oh, we have G here for sure. J, okay, so that's allowed. So we can erase. Okay. Seamus tests F on the first day. So F, G, and G. This can't be, can't be J or G, so it's got to be F, right? Because F can't be here. And it can't be J. Okay, so what do we have here? We would have H here for sure, and then J is the only one left over there, and then J would have to be here. Yeah, okay. So definitely still possible. Teresa tests F on the second day. Alrighty, so F here. These are both G's. This can't be J, G, or F. So it would have to be H. This would be J. We'd have to put J here. Ooh. But then we have an F left over, and we can't put F there. So there is no way to make that one work. C is not going to work for 16, which makes it the correct answer, right? We're looking for something that cannot be true. Question 17. Teresa tests J on the first day. Okay, so we're dealing with this scenario here. J on the first day. J on the second day can't be this guy, so it has to be over here. Okay, and then F. So this could be H or G. So I don't know if this is G or F. Let's see, which one of the following could be true? So R tests G on the second day. Nope. Seamus tests H on the first day. So this is H, this is G, this is F, G. So no problem with that. That won't be allowed. So B is the correct answer for question 17. Which one of the following cannot be true? Okay, so both R and S test J. Now this is where a bank of acceptable solutions would be really nice. But we'll just try to make that up. Okay, so R and S test J. Okay, so it would have to be like this. I don't know for sure if T would have to have H down here, but we'll just see if we can make this work. So JJ, let's go ahead and put H here. F, F, G, G. No problem with that. Both R and T test J. And T test J. So what if we put the J over here now, G here? Don't see anything wrong with that. R and Y test G. R and Y test G. So what if we put G, oh sorry, R and Y test G, yeah, put G here, H here, not breaking any rules. That would be okay. S and T test G. No. Nope. Not gonna work in this world, right? Because the only way for those two to both test G would be if they test it both on day one. So we would have to try it over here. We can still try it over here, but let's see. G, G, this would have to be F. This can't be J, which means it would have to be H, but then we run into a problem where we would have J tested by R on both days. Not allowed. So D is the correct answer here. Let's just show that T and Y can both test F. So if they both test F, T, and Y, it's going to have to be here so that they're on different days, right? They can't test F on the same day as each other. So we'd have F, F, this is G, G. This can't be H. This has got to be H so that these guys aren't the same. And then we'd have J and J, and that would be allowed. Okay? Let me know if you have any follow-up questions.